To keep troops safe and get boots on the ground, engineers have devised 3 truly extraordinary military machines. The C-17, one of the largest and most impressive aircraft in the skies. Capable of delivering soldiers and heavy cargo into any location on Earth.
The C-17 is the most important aircraft that we have in our Air Force inventory. If you bring it, we sling it. If it fits, it ships.
The Stryker, a high-speed armored infantry carrier that combines pace and power. Engineered to overcome the challenging terrain of modern combat zones.
The operational reach of the Stryker is really something impressive. It can move very far, very fast. It really feels like you're in charge of a lot of combat power and you got a lot of assets.
And the brand new ACV, 30 tons of floating amphibious attack. This prototype aquatic assault vehicle can seamlessly transition Marines between sea and land.
This vehicle is on the cutting edge of the Marine Corps' push towards a new amphibious fleet, and this vehicle is imperative to our success.
The C-17 can transport more than 130 troops, or cargo weighing up to 85 tons to any location on the planet. The Stryker is an 8-wheeled armored personnel carrier. Each one can carry 11 soldiers to the front line at high speed and move seamlessly from on to off-road. The ACV is an amphibious combat vehicle to take 16 infantry directly from ship to shore and into the fight. Together, these 3 mighty machines offer the troops the solutions they need to attack from air, land, and sea.
The more we empower the soldiers to fight the battle and be able to adapt, increases their opportunity to be successful. When used effectively, right, the set of tools can make them way more efficient on the battlefield.
But in order to deploy this trio of vehicles successfully, engineers must solve a series of problems. How do you land and stop a giant aircraft loaded with heavy cargo? And how can you touch down in locations without runways?
When the Air Force came out with their requirements, initially the engineers all said that it wasn't possible. Nothing like this had ever been done before.
How do you move troops quickly across the challenging terrain of the front lines?
The Stryker is provided an interesting challenge with how to safely and quickly move the soldiers on the battlefield.
And how do you build a 30-ton tank that can swim?
The Marine Corps has to have a means of quickly and efficiently getting the troops from ship to shore from greater distance than we've ever had in the past.
When the military need to transport the troops,
I move tactically.
Engineers have equipped them with 3 extraordinary vehicles to tackle land, sea, and air. The C-17 is one of the world's largest and most powerful aircraft. This aviation giant is a key for getting boots on the ground and equipment where it's needed. The C-17 has the capacity to carry 134 troops, or up to 85 tons of cargo to the front lines. It can transport as many as 8 Humvees, or a massive Abrams tank. At Travis Air Force Base, outside Sacramento in California, it's Loadmaster Drew Gayhart's job to make sure the C-17 can deliver troops and cargo into even the most extreme and dangerous environments.
All right, right now we're in the back of a C-17 Globemaster 3. This back here is the actual business end. The pilots up there, they get us where we need to go, but everything back here is the full mission, getting this stuff where it needs to go. We got 88 feet of carrying capacity, up to 170,900 pounds of cargo we can fit back here. Anything from a tank to helicopters to paratroopers. There's always inherent danger when you're trying to supply troops on the front line. If we can't land the aircraft in a conventional way, it is critical that they get the right equipment they need at the right time.
But how do you deliver tons of heavy cargo from a height of 20,000 feet to an ever-moving front line?
There'll be one rendezvous and then radial DMEs down. Yeah.
2-1 right, clear for takeoff. Beeline or 2-1 heavy.
Military engineers came up with a mind-blowing solution. A process known as auto-extraction.
When we are over our target location, we open our ramp and door in flight and release the first smaller parachute, which would in turn pull out another bigger parachute, which is going to actually pull out our cargo. Once the cargo is out away from the aircraft, another set of parachutes will open to stabilize it and prevent it from falling too hard or too fast. Upwards of 100,000 pounds can be airdropped out of the back of this. So you could have a huge vehicle, whatever the troops need there. We can drop supplies and get them what they need to have, no matter where they're at. It is awe-inspiring to see how much you can deliver out the back of an airplane, thousands of feet above the ground, going 500 miles per hour.
It's always surreal every time it happens.
Oh yeah.
But the C-17 doesn't just airdrop troops and cargo. It can also land in near impossible places. It's Lieutenant Colonel Steve Nolan's job to get the C-17 on the ground in battlefield locations that lack proper runways.
We received the call saying you gotta go. We can get there in a moment's notice. Engage auto throttles, engage auto throttles.
So in any type of operation, you have to get the troops where they need to be, when they need to be there. Whether it be a sheet of ice in Antarctica, a dirt strip in a combat zone, we need to land this aircraft.
But with the C-17 weighing up to 292 tons when fully loaded, how do you safely ground this monster machine in such challenging conditions? Could part of the answer lie with a heavyweight pioneer from the past?
Oh, wow. This is really something.
Engineer Dan Dickrell has traveled to California
This is really, really impressive.
to see one of the most important aircraft of all time.
Well, here she is, the B-47 Stratojet. This is the mother of all modern jetliners. It all starts here.
Designed in 1945 by George S. Scherer and a team of Boeing engineers, the B-47 was one of the largest and most powerful jets in the sky. But safely landing this 66-ton aviation heavyweight posed engineers a real challenge.
106. Visibility 10.
Let's go fly.
To understand the problem for himself, Dan's taking to the skies in something much smaller.
One of the funny things about landing an airplane is when you're actually doing the landing, you have to accelerate, you have to speed up in case something unfortunate happens, some sort of mechanical failure, whatever reason to abort that landing. You have to have enough engine capacity to speed back up and take off.
Known as a go-around, it's an essential maneuver to help pilots avoid accidents on landing.
What we're going to try and do is, with this particular airplane, recreate that experience. Now, we're going to touch down very briefly, and all of a sudden, something wrong. Full throttle, back on. Yeah, trying to get it back up off the ground.
Because the B-47's engines were so slow to accelerate, it had to touch down at 155 miles per hour in order to carry enough speed to get back in the air.
In this particular airplane, it's pretty exciting, but imagine what that would be like in a B-47. Those 6 engines screaming, trying to get it back off the ground.
But this high speed required to go round created a problem for regular landings. How to stop safely when you're traveling so fast?
You've got one of the biggest, heaviest aircraft in the world at that point, carrying a lot of speed. That must be quite an experience for those pilots back in the day.
Touching down at 155 miles per hour meant a real risk of putting the aircraft into a dangerous skid. Pilots needed a way to put the brakes on the B-47 safely. And George S. Sciarra and the team at Boeing had the answer.
To show the solution the engineers came up with, I've got this BMX bike. Let's take it for a ride. This is every kid's dream. Riding his BMX bike up and down a runway. All right, so I got myself up to speed. Like a B-47 coming in for a landing. If I apply the brakes, whoa, I skid to a stop. Now that's a situation you don't want in an aircraft. The reason why it happened is because I built up so much forward speed that when I applied the brakes very strongly, the friction between the tires and the runway wasn't sufficient to stop me. So until that speed had reduced, I just skidded along the runway.
To eliminate this risk, the B-47's engineers introduced an aviation first: anti-skid brakes.
All right, here we go. Now this time, when I bring myself to a stop, instead of slamming on the brakes, I'm gonna pump them as much as I can, coming to a controlled stop. In essence, that's how an anti-lock brake or anti-skid system works.
The B-47's wheels are fitted with sensors to detect if the aircraft is braking too hard and likely to skid. Hydraulics to the brakes are cut and reapplied, allowing the wheel to roll freely and stop safely.
This really is an iconic bit of engineering. The technology that it's built on is as relevant today as it was the day it took off. It's incredible.
On board the C-17,
Beeliner 21, heavy radar contact 2 miles southwest of Travis.
Beeliner 21.
pilot Elijah Height can count on the anti-skid brake technology pioneered on the B-47.
Right turn 010, Beeliner 21.
But to land a plane almost 4 times the weight of its historic inspiration into locations lacking runways, engineers had to supplement the anti-skid brakes with an entirely new system known as blown flaps.
Flaps up, gauge 250 on thrust, 250 on thrust.
It's all about making the surface area larger of the wing. The flaps extend a essentially more than half of the wing surface.
In combination with its modern responsive engines, blown flaps mean the C-17 can fly far slower into landing than the B-47.
That allows us to stop in an insanely short amount of distance.
The only airplane that can do the things that it can do. It's pretty incredible.
Blown flaps direct engine exhaust downwards, creating huge amounts of lift at low speed, allowing the aircraft to make slow, steep approaches and stop in a short distance.
Alright, slats extend, flaps 1/2, index 99.
By utilizing blown flaps and anti-skid brakes, C-17 pilots can make seemingly impossible landings.
In comparison to a conventional aircraft that might need 7,000 to 9,000 feet of runway to stop, we can do it in just about 3,500 feet or less. The full flap configuration allows us to be able to fly very steeply and slow. A huge portion of our thrust is hitting our flap panels, and that creates an enormous rumble inside the aircraft. It's pretty incredible to be able to have that blown flap concept, and really it makes the aircraft an incredible piece of engineering.
The C-17's ability to land almost anywhere is essential for delivering troops and cargo to the front lines. Thanks to its giant wings equipped with blown flaps and huge cargo bay to carry enormous payloads, the C-17 can achieve feats that would be impossible for other aircraft. To support the soldiers on the front lines, engineers have introduced 3 mighty machines. The massive C-17, the cutting-edge ACV,
All right, close your hatches.
and the Stryker, one of the fastest land combat vehicles in the world. Designed to carry a squad of 9 soldiers across the demanding terrain of modern combat zones, the Stryker's ballistic steel and ceramic armor shell sits on 8 giant wheels. It can hit speeds in excess of 60 miles per hour. In Vilseck, Germany, 2nd Cavalry Regiment are out on high-stakes live-fire Stryker training.
Circle back around and move back to the dismount point.
Sergeant First Class Nicholas Young is military advisor for the Stryker Brigade combat team.
When you're operating any combat vehicle, there's a multitude of terrain where you might see, right? Whether it's improved roads, unimproved roads, trying to travel off-road or sand, mud, all of those are things that you might encounter in a combat vehicle, trying to get from one place to the other on a battlefield.
To ensure the troops can tackle the challenging conditions on the front lines, engineers must look to the pioneers of the past.
Okay, ready?
Yeah, okay.
Hold on. Come on, baby.
Oh, this is steep business.
Engineer Dan Dickrell is on the Hell's Revenge Trail in the Utah desert.
Pretty sure we're gonna make it up?
Where owner Gavin Harrison is putting an icon of military engineering through its paces.
I cannot believe we're making it up. This is an amazing experience. Oh Almost to the top.
The Willys Jeep is one of the most important vehicles of all time.
All right. Man, that was outstanding.
The result of a collaboration between automotive pioneer John Willis, Ford, and the Bantam Car Company. The Willys was developed for the US military, who wanted a fast and agile vehicle that was capable of truly extraordinary feats off-road.
So in two-wheel drive, we're gonna attack this pretty aggressive section of the trail.
Prior to the introduction of the Willys, two-wheel drive was the standard, making traveling off-road a real challenge.
Slide it up here. We got up that section. Now, here we go. Whoa, yeah. Gotta keep smashing it up here, but I don't think this is gonna work.
With only two wheels delivering power, getting in a spin was a common problem.
The back wheels are doing as much as they can, but they're slipping. The front wheels are doing nothing. Yeah, let's just call it. That's enough. All right, so in two-wheel drive, this vehicle almost made it, but not quite. It's just too aggressive. The problem is the way that the power is going from the engine to the back wheels. There's just too much spin, and the slick rock, lots of dirt, gravel. There's just not enough grip.
But the Willys had the answer, making such problems a thing of the past. It was the first mass-produced vehicle with four-wheel drive capabilities, an achievement made possible by an innovation known as a transfer case. By shifting a set of gears inside the transfer case, the Willys can switch between sending power to just the rear wheels and sending power to all four wheels. This ability to engage four-wheel drive transformed off-road performance.
Let's see how we do, man. Let's hit it. All right, so we're gonna approach this same section that we tried to do in two-wheel drive, except now we got four-wheel drive. The transfer case did its job. It's gonna send this engine power to the back wheels are gonna push, front wheels are gonna pull, using the same line that we did before. Oh yeah, much different. Twice amount of grip, twice amount of traction. Yeah, we've already made it past the section that we got stuck before. Now just this last bit. See those tires flexing. And we are through. That was excellent. Awesome. That was very, very good.
The introduction of four-wheel drive allowed the Willys to conquer terrain that would have previously been thought impossible.
Seeing this thing in action, really understand how much of a game changer the Willys was. Having access to a vehicle that can take you anywhere in almost any condition, it was a winning combination on the battlefield.
The engineers behind the Stryker have taken the four-wheel drive technology pioneered in the Willys and doubled down. The Stryker is an 8-wheel drive vehicle, capable of seamlessly transitioning from on to off-road at speeds in excess of 60 miles per hour. This all-terrain ability is key for keeping the troops moving on the front lines.
So whether it's driving on the highway or driving, in wood or sand or snow, the ability of this vehicle to get through those terrain is ideal.
The Stryker is enhanced by a secondary off-road system known as CTIS, or Central Tire Inflation System.
So the central tire inflation system runs the air pressure from the vehicle into the tires. You can see the hose lines, which will inflate them or deflate them based on the terrain you're traveling on.
CTIS enables the crew to change tire pressure with the push of a button. A series of sensors and pressurized hoses attach to each tire from a central air supply. Tires can be deflated to give additional traction off-road and inflated to increase performance when driving on-road.
Having the ability to inflate or deflate the tires is advantageous to the crew because it allows them to maintain maneuverability on the battlefield regardless of the terrain they encounter.
6 is 1-6. We're moving the J's ahead to cover his movement from a farther forward position. Over.
But the Stryker is not only about moving troops at speed. Its ballistic steel armor also helps keep them protected. However, the price of such protection is a lack of visibility.
Is this the dismount point? The trade-off of being inside an armored vehicle is that you never know where you are. This looks like the dismount point. So anytime you put a window in an armored vehicle, it's a place where there isn't armor, so it's a threat to your safety. Stop.
So how do you stay aware of your surroundings while also staying protected? The Stryker is fitted with a DVE, or Driver's Vision Enhancer. Powered by top-secret technology, this advanced thermal imaging camera enables the crew to see their surroundings from a protected position.
It used to be that you had to expose yourself to get situational awareness in the vehicle. And now with the DVE, you can do it while staying behind a cover position. What do you see? I need 200-meter warning and 100-meter warning for the dismount.
So one of the key advantages to using a DVE is it allows the driver to see in all weather conditions as well as daytime and nighttime to effectively see in order to maneuver the vehicle. Even when it's dark, we can still have the opportunity to see a lot more of the battlefield.
With a 170-degree field of view, the DVE offers impressive visual support.
200 meters. If I didn't have this video feed inside the vehicle, every time we dismounted, it would take a couple minutes to figure out where we were and where we need to go. With this, I know exactly where we are and lose no time transitioning from mounted to dismounted. 100 meters. So when it comes to spotting enemy, every second matters.
Hey, dismount VC!
Dismount, dismount, dismount!
But staying aware of your surroundings isn't always enough to keep soldiers safe from harm. To keep American troops on the front foot, the Stryker needs to offer some offensive power of its own.
Being able to come to a fight and be able to match or overmatch the enemy is extremely important. Combining the Stryker with the 30mm cannon brings a lot more capability to the battlefield, and it provides us a threat that we didn't have before. The other things that the Stryker brings to the fight is the Mark 19 40mm grenade launcher, which is equipped with the Javelin missile. It's equipped with the weapon station. The Stryker is a very capable vehicle.
In order to empower the infantry, engineers have designed a trio of incredible vehicles. The C-17, one of the largest aircraft in the skies. The Stryker, a high-speed armored personnel carrier. And the ACV, a 30-ton amphibious assault vehicle to carry Marines from ship to shore. Each ACV can hold 16 people. Powered by twin propellers at the rear, it can swim through waves more than 6 feet high. At Camp Pendleton in San Diego, California, engineer Dennis Fitch is amongst those working on the development of the Marine's latest amphibious asset.
It's very challenging to combine both water and land mobility and still have survivability. Survivability components tend to be very cumbersome and heavy, but we still have to have the ability to swim through the surf.
So how do you engineer a 30-ton armoured vehicle that can achieve all of this? To find a solution, the team behind the ACV must look to the innovators of the past. In the British Midlands, a remarkable piece of wartime history could hold the answer.
Okay, here we go. Come on.
As engineer Rhys Morgan is finding out for himself.
Oh, I'm loving this. This is great.
This is the Valentine.
Wow, this is just extraordinary.
17.5 tons of armoured infantry tank.
The power of this thing, the noise, the smells, it's just incredible. I can't believe it.
Tanks were essential for the Allied effort during World War II. But the landing craft required to get them on the beaches was slow and vulnerable to attack, leaving troops lacking the support they needed. To get tanks ashore safely, Major General Percy Hobart and engineer Nicholas Straussler proposed a radical solution.
All right.
The concept was so ambitious, even now it seems impossible.
The idea was to find a way to make the tank swim, which, when you look at this thing here behind me, seems totally ridiculous. But Hobart and Straussler had a brilliantly simple solution. Now, if we imagine my brick here is my tank, they're both really heavy. When I drop it into the water, it sinks to the bottom. That's because the brick is more dense than the water, and so it pushes the water out of the way. There's a really easy way of changing this outcome, and that is to change the density of the brick, and I've got one just here. So what I've done here is add a plastic screen around the top of the brick. So now I have an object that's about 50% larger, and it's less dense because 50% of that volume is just air. So now when I place it in the water, it floats. What a brilliant, simple solution. With the screen added, the brick is much less dense, so the water can push back against it, enabling it to float.
By applying this idea to the Valentine, Hobart and Straussler developed one of the most ingenious pieces of wartime engineering ever conceived.
Okay, Dan, let's turn on the valve. Oh my God, it started already.
An inflatable flotation screen.
The compressed air line is starting to fill these rubber tubes and lift the frame. Wow, you can really start to see it now. It's starting to gain some height. As the pressure increases in the tubes, they pop up, locking the frame into place. Wow, this is such an incredible feat of engineering. I can't believe the compressed air has just lifted this whole structure up. This is almost identical to the brick that we saw earlier. We have a heavy base, but then this enclosed volume of air on the top, and that reduces the overall density of the object.
With the screen inflated, the Valentine could float, but it still needed a way to move through the water.
There's a propeller underneath to drive it. Now that is engaged by the commander, and the commander would stand up here looking down the length of the tank over the screen to the beach and then steer the tank onto the beachhead. Just amazing.
Because the Valentine's engine could power both propeller and tracks, this system became known as Duplex drive.
To think that this 17.5-ton tank can float in the water and just ride up onto the beach, it's just incredible. I mean, this is impossible engineering right here.
Testing the flotation screens began in 1941. And by 1944, this incredible technology allowed tanks to achieve the seemingly impossible: to swim onto the beaches of Normandy on D-Day.
Getting tanks onto the beaches was key to swinging the war in favour of the Allies. What an incredible piece of engineering.
Just like the Valentine tank, the ACV has been specifically engineered to get troops from ship to shore. Marines Captain Grayson Heiner is Amphibian Assault Vehicle Officer for the ACV program.
With this vehicle, you can see, first thing first in the front, we have a trim vane. This trim vane folds up and can be deployed forward while conducting amphibious operations. What that does, it gains us stability in the water, and it keeps water from flowing over the front end of the vehicle. When the vehicle is in the water, embarked with its troops, the water line is going to come up to about 3/4 of the way up this panel right here. So a very small footprint of the vehicle is going to be visible from the shore. So what that translates to for us is increased stealth and the ability to come ashore without being noticed.
To keep the 30-ton ACV afloat, engineers have taken the concept used on the Valentine's flotation screen and updated it. The combination of classified buoyant materials and the vehicle's large empty internal space means the overall density of the ACV is less than water.
It's a massive feat of engineering to have a vehicle that's this heavy, this large, that has this majority of its structure underwater, and something that can still be buoyant and survivable in pretty heavy seas. So that's definitely a great feat of engineering.
And the ACV has adapted the Valentine's technology in other ways.
So these propellers are tied into the drivetrain of the vehicle so that this vehicle can utilize both propellers and wheels at the same time. And what that grants us is propulsion in the water, as well as when we're transitioning from the water to land, we can do it seamlessly by utilizing the wheels at the same time. So we come from the sea, utilizing our propellers to push us forward, and then once we hit the ground, we can immediately employ the wheels. This package gives you the survivability that the Marine Corps deserves and it needs. It's going to protect the infantry Marines in the fight and on the battlefield, and it's going to keep Marines alive.
Just like the C-17 and the Stryker, the ACV allows the infantry to overcome the challenges they encounter. And the feats these three military machines have achieved are truly mind-blowing.
The fact that the C-17 can land anywhere on the planet is just an absolutely phenomenal feat of engineering.
Stryker has been employed in Iraq, Afghanistan, as well as other theaters of operation that allows the infantry soldier to be successful.
It's very humbling to see what we're capable of when a lot of really smart and talented individuals come together to solve a problem.
Thanks to the C-17's ability to land almost anywhere, the Stryker's robust off-road performance, and the ACV's capacity to move with ease across the water and the land, soldiers are equipped to conquer seemingly impossible problems. Thanks to the engineering behind these three incredible vehicles, the troops that operate them on the front lines are empowered.
It's great having a vehicle that can transport not just the soldiers and their equipment, but also a lot of additional gear and firepower.
By looking to the past for inspiration,
Whoa, yeah!
improving on pioneering technology, modernizing and upscaling ideas, and accomplishing new feats.
To drop cargo upwards of 60,000 pounds from 20,000 feet off the ground, it was something that had never been seen before, and it took some pretty incredible engineering to make that happen.
Engineers have provided the infantry with the tools they need to deploy from the air, the land, and the sea.
When you're in charge of vehicles like this, it really feels like you're in charge of a lot of combat power and you got a lot of assets. It's really kind of thrilling.
They've succeeded in making the impossible possible.